So now, what I am going to do today is is it visible? The slide is visible to you? Can you read me out? Read out this. Yeah. Read out that slide. Is it visible? Hello? Hello?
Hello, yes, sir.
Yeah, just read it out. What is seen on the screen?
Quest embryo class 11 chemistry 1.
Yeah, it's fine. So the other one is my name and my email ID. So if you want to mail me something, you can always mail me at that address. Anyway, that just so we will in this lecture or in this discussion, what we are going to do is I am going to introduce the basic concepts in science. What is science? What are the branches of science? Then, like, then we will come to chemistry. What is the importance of chemistry? What do you understand by chemistry? And what are the things involved in chemistry, etc. Then we come to our what is the topic which we are interested in. So that is the kind of approach we will be using. So let me ask you this question. What do you understand by science? Chemistry is, after all, a part of science, isn't it? Yeah. What is science? What do you understand by science? Yes? Hello?
Science is a branch which studies about chemicals, all
No,
different
I'm
stages.
talking about, no, okay, that is chemistry. Chemicals comes in chemistry. So what is science? Chemistry is a branch of science only. So what is the superset is science? What is science? Yeah, Karan. Hello. No idea.
No, sir.
So you have been studying science all of these years. So what is your understanding of science? If somebody asks you, what is science? What is your answer to that? Yeah. No idea.
No, sir.
Is Karan still there or he's gone?
She's there.
So I'm there. I have no idea.
So you have no idea about science, huh? Anyway, so let me get into the next slide. So this is, see, actually it's again the human creation. And generally it answers our whys and why something happens and how something happens. So that is, the science answers that. First thing, why something. So why, for example, like why the apple or the coconut or an apple falls down, or how, what is the uh, how water is formed, like like so this uh, like again it's originates, the scientia is a Latin word, means to know. So science means to know. That is the meaning of the word scientia. That is, so from scientia the word science came. So now you have for our convenience we have divided science into various branches. So what are the branches of science?
Physics, chemistry, and bio.
Yeah, these are the basic, these are the core branches of science. Like you talk of physics, we talk of biology, we talk of chemistry. These are the core branches, because each branch has further sub branches. Physics has. Do you know any branches of physics? What are the topics you study in physics?
Quantum physics.
Yeah. See, generally we talk of electricity and magnetism. So they have a different branch. Then you have mechanics, like and mechanics have statics and dynamics. Then you have nuclear physics. Then, which I told you earlier, electronics. So like that, you have branches in physics like that. And what about biology? What is biology? So I know.
Study.
Let me. Anyway, just before that, what is physics? Again, yeah. What do you understand by physics? Study of? You are telling something.
So I was saying about biology.
Okay, we'll come to that. Let us discuss about physics first. Yeah. So what is physics? So again, it's a Latin word. It is originated from Latin. It's sorry, Greek. It has originated from the Greek word physica, physics. That is nature, study of nature of things. Okay, that is the meaning of the word physics actually. But within physics, you study about motion, about the stationary objects, then the origin of universe, then you talk of nuclear physics, then you talk of electricity and magnetism. Then another branch is, have you heard of the branch optics? Optics, have you heard of optics?
No, sir.
No, sir.
Have you heard of light and light?
Yes, sir.
Study of lights is known as optics. You might have studied about reflection. 10th, you might have studied about reflection, refraction, dispersion, etc. Isn't it?
Yes, sir.
So that branch is known as, study of light is known as optics. Again, it is coming from the Greek word. So optics is the study of light. Then you have electricity and magnetism. Then you have the study of what is nuclear? Have you heard of nucleus? Nucleus. See, you have you know about atoms, no?
Yes, sir.
So
Sir.
so, uh, so atom has a nucleus. Have you heard of that?
Yes, sir.
So what are the things inside the nucleus?
Proton and neutron.
Yeah, proton. Basically, protons and neutrons sit in the nucleus. So study of those, the nucleus is dealt with in nuclear physics, etc. So it's basically physics means study of nature of things. Yeah. That anyway, we are. I'm not going into details of physics because we are going to get into chemistry. And then before that, sorry. Then coming to biology. What do you study in biology, or what?
It is a
Yeah.
study of living organisms to know about them.
Yeah. So actually, you're right. Actually, the again it is a Greek word. Bios means life. Logos means study. It's a study of life actually. So living organisms. What can you give me examples of some living organisms?
Humans, plants, animals.
Plants.
Yeah. So you have one kind of thing is plants. So the study of plants are known as, what is that branch of biology which study about botany? That is about the plants. And then study of animals,
Zoology.
Zoology.
zoology. So you have basically the biology is divided into two parts. First, like you have the botany and zoology. And what about study of human beings?
Anatomy.
Anatomy.
And see, actually, there are two, three. One is anatomy, is how your human body. Then you talk of physiology, that is again of the human. Because when you are going to the medical field, when you are as a doctor, you will be, when you are joining like MBBS course, the bachelor's course in medicine, there you will be studying in detail about the different aspects of human body. So that you will be discussing about the anatomy, then you will be talking about physiology and things like that. Of course, you will have a basic in your biology, 11th and 12th, you will be dealing the basic concepts in botany and zoology. But more detailed understanding of uh, human biology, we can say, that you will be dealt with in your bachelor's course. Yeah. Now coming to chemistry. Chemistry has a very interesting. What do you understand by chemistry, and what do you do in chemistry?
So,
Chemistry deals with the study of chemicals.
Yeah, actually there are. Actually, it is not. What do you mean by chemical? What is a chemical? You said chemistry is the study of chemical. So what do you understand by a chemical? See, when you are talking about something, we need to understand what we are talking. Like, we cannot arbitrarily take words. When we say chemical, what do you understand by a chemical? Tell me, please. Go ahead. Don't feel like, don't hesitate. Just come out. Yeah. What do you understand by a chemical? Can you give me an example of a chemical? No answer? Hello? 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 Are you there?
yes, sir.
So I'm getting confused. When you are silent, I don't know whether you are there or you are not answering. So because you have to make sure, I mean, I have to be sure that you are there. So he's like Karan. I mean, just again, I'm not getting your names properly, but let me say Karan. Karan is saying uh, chemistry means study of chemicals. Tell me, what is the meaning of a chemical? What do you understand by a chemical? Yeah,
So, no idea.
no idea. And Karan,
No idea.
then you have used the word chemical. Then you should have some idea. Uh, without any idea, how can you say that? See, actually, everything is made of chemicals. If I say this, do you agree with that?
Sorry, sir.
Everything is made of chemicals. So if I say this, will you oppose it, or will you agree?
Agreed.
Why? Why you should agree? Eh? Why should you agree? Because I am telling. That's why. Is it because I have said so you are agreeing, or any reason for that?
Sir, because everything we see around us
Hmm.
is made up of chemicals, like
No,
atom.
if, to understand that, you have to understand what is a chemical. Chemical, see, it's actually, we are giving a different name for the matter. Have you heard of matter?
Yes, sir.
Are you familiar with what is a matter?
Anything that has space and or anything that has mass and occupies space.
Yeah. So we know that things around. Can you give me an example of matter
Air,
around it? Hmm?
air,
Yeah.
table,
Then,
chair.
yeah, all these are made of matter actually. So, so another name we can say, it's chemistry is a study of matter and its transformation. What do you mean by transformation? Can you give me an example of a transformation? transformation of matter?
So I have no idea about transformation.
Transformation is changing from one. See, for example, this is not the first time you are studying chemistry. You have studied chemistry from which class? Which class onwards you are studying chemistry? Fifth, sixth, or sixth? Yeah. So how water is formed?
Combining
Water.
hydrogen and oxygen.
Yeah. So there are two matter. One is hydrogen. One is oxygen. When they join together, a new matter is formed. So that is the transformation of hydrogen and an oxygen into water. So we talk of a chemical reaction there, but in simple terms, it is a transformation from both of them are gases, isn't it?
Yes.
Hydrogen is a gas, oxygen is a gas.
Yes,
Whereas
sir.
water,
Liquid.
so in chemistry, we deal with matter and its transformation. Okay, we will come in the more details about that because our basic discussion is about chemistry. So again, have you heard of branches of chemistry? Branches?
Yes, sir.
Yeah, tell me. What are the branches of chemistry?
Inorganic.
Yeah, what is inorganic? So you have inorganic chemistry. Yeah, so that means you have organic chemistry also. What is the difference between organic? So let us start with organic. What is organic chemistry? You have organic chemistry. It was later, as I see in the syllabus, you have organic chemistry, isn't it? Is it there? Have you
Yes, sir.
seen the syllabus? Yeah. What do you understand by organic chemistry? Yes. So you people are not answering. Whatever it is, what comes to your mind, you should tell me. What do you understand by organic chemistry?
Study of carbon containing compounds.
Yeah. So organic chemistry basically deals with, say, you have just see carbon is one of the, again, you might have heard of elements and compounds, isn't it? See, because I'm bringing in terms which you are familiar already. So you have heard of elements? What is an element? Not heard of them?
Element. Element
Can
is
you
a
give me
pure
an, yeah, example? Give me an example of an element.
atoms.
Pardon? Name of an element.
Water.
Water is not an element. We'll come to that because just before we said that water is made up of hydrogen and oxygen. So water is a compound. It is not an element. Whereas hydrogen is an element, oxygen is an element. Okay, because it can what hydrogen contains atoms of only hydrogen. Then oxygen contains only atoms of oxygen. Okay, so then we say they are elements. Hello,
Yes, sir.
Yes, sir.
so you understand? So element is something which have it contains only atoms of one kind. That means hydrogen. If you say hydrogen is an element because it contains only hydrogen atoms. Oxygen is an element because it contains only oxygen atoms. So what is an atom? That brings us to us an atom. What is an atom? Yeah, tell me.
Atom is the smallest particle of an element,
Yeah,
and it is the unit of chemical.
yeah. Yeah, please repeat. I was
Atom is the
distracted.
smallest particle of an element.
Yeah, so it is, and which is showing all the properties of that substance. For example, hydrogen atom will show all the properties of hydrogen. Can I divide atom further? Can I split atom further, or atom is the smallest?
Atom
Can
is
I
the
divide?
small.
Yeah. See, actually, atoms can be further divided, but just like Karan was telling, atoms are the smallest particle which shows the properties of that particular matter. For example, hydrogen atom will show all the properties of hydrogen. Suppose we split hydrogen atoms. What are the things? If I split hydrogen atom, what will you get? Suppose I split hydrogen atom. So what I will get? Will I get something?
No, sir.
Yeah. Karan,
Yes, sir.
if you divide hydrogen atom, what will you get?
Hmm.
You don't get anything?
Maybe we will get nothing.
Pardon?
No.
We cannot split. See, actually, if you divide atoms, you will get, see, for example, hydrogen has one proton and one electron. So if you split further, you will get one proton and one electron. So that is similarly other atoms also. If you split them further, you will get what is there in the nucleus. Say, for example, you get some of the atoms have uh, neutrons and protons. So if you divide further split them, you will get electrons, protons, and neutrons. So that is one division possible, but it will not show the properties of the element which you are talking about. For example, if you split hydrogen into proton and electron, it will not show the properties of the hydrogen. Similarly, for oxygen, if I split the oxygen atom, it will not show the properties of oxygen because it will be split into proton, neutrons, and electron. Okay, so element is the like element atomic atom of an element shows all the properties of the element. But if you and you know the meaning of the word atom, what do you understand by atom? This is a literary meaning. Like we have seen the meaning of the word biology, we have seen the meaning of the word physics. So what is the meaning of the word atom? Have you heard this? No, you may not have heard because you don't do any extra reading. So that is why. Atom means, again in Greek, Greek or Latin, I don't remember exactly, but it means something which is indivisible. Just like Karan was telling, it is indivisible. That is what people thought, that atom cannot be further divided. Earlier, people used to think, especially, I think it is Dalton, which gives the atomic model. First atomic model was given by him. So atoms are indivisible. The meaning of the word atom is indivisible. But today we know that atoms can be divided further. Okay, atoms
Yes,
can
sir.
be further. So now today's definition is atom is a matter which, or an element, part of the element which show all the properties of that element. That is known as an atom. Now coming to compound. What is a compound? Yeah.
Compound is a substance that is obtained by mixing two or more elements.
Yeah. So examples, can you give me some examples of a compound?
That's water.
The water is a compound made of hydrogen and oxygen.
Oxygen.
And then any other compound? Can you give me?
Hydrochloric acid.
Pardon?
Hydrochloric acid.
Hydrochloric acid. Hydrochloric acid, which all elements are there in hydrochloric acid?
Hydrogen and chlorine.
Yeah, hydrogen and chlorine. Another example,
Ammonia.
ammonia. And which all elements are there in ammonia?
Nitrogen and hydrogen.
Yeah, nitrogen and hydrogen. Then now let us one by one, you tell me, like both of you should join in this. First, let us take the names of some elements. Yeah, one by one, you tell me examples of elements.
Hydrogen,
Yeah. Next, Karan, give it one example.
Carbon.
Yeah. Again.
oxygen,
Yeah.
Neon.
Yeah.
chlorine,
Yeah.
Fluorine.
Yeah.
sulfur,
Yeah.
Helium.
Yeah.
argon,
Yeah.
Radon. Radon.
Pardon?
Radon.
Radon. Okay, you are very fond of inert gases, it seems. You have taken neon, helium. These are special category of elements. You know that, no? What is the speciality of, if I ask you, what is the speciality of helium, neon, argon, and radon? Anything
their
special about them?
the outermost shell is complete.
So, but we don't see their outermost shell. Yeah, that textbook says outermost shell. Any other property which you can tell me? They are known as inert gases. See, of course, what you said is right. Their outermost shell contains, except helium. Helium, how many electrons are there in the outermost shell?
2,
2.
2. Yeah, all others have 8 electrons in the outermost shell. So, they are popularly known as inert gases. Why they are known as inert gases?
because they don't take part in chemical reactions because the
Yeah,
outermost shell is complete.
yeah, yeah. So we will be discussing about that. So they are the particular category of elements which are known as inert elements or inert gases, because all of them are in the gaseous form. So you talk of call them as inert gases. Now, now let us take examples. So there are actually in nature almost around 92 elements are naturally occurring elements are there. Then human beings have created some artificial elements also. Up to you. So you have seen hydrogen to uranium up to 92 elements are naturally occurring. That means it is available in nature on Earth. So, but after that, we have created some new elements, which is trans uranium. That means after uranium, we have created many, uh, artificially, we have created some elements also. So there are two categories of elements, that is naturally and like which exist in labs and things like that, or in between they are created and things like that. So that is there. Now let us take the examples of some compounds. Yeah, tell me. Start.
Water,
Yeah,
Carbon dioxide.
you're right. Again.
hydrochloric acid,
Yeah,
Sodium sulfate.
yeah. Which sodium sulfate, which all elements are there?
Sodium and sulfur.
Yeah, sodium and only sulfur. See, actually, sulfate means oxygen. With this, there is a nomenclature rule. Nomenclature means how to name. So when we take off sulfate, that means it will be having oxygen also. That means it will be having sodium, as your name suggests. Sulfate means sulfur will be there. Then 8 means sulfate means it will be, otherwise it will be sodium sulfide. If you say sodium sulfate, it will be having only sodium and sulfur. If you say sulfate, that is pH 80, sulfate, SUL pH 80, sulfate means it will be having oxygen also. So that means sodium, sulfur, and oxygen is there in sodium sulfate. Anyway, another example.
Sodium chloride,
Yeah, sodium. Which all elements are there?
sodium and chlorine,
Yeah. Suppose I say sodium chlorate. Which all elements will be there?
chlorine and oxygen,
And sodium, of course. Sodium will be there. Yeah. And now next example of a compound.
Ammonia,
Yeah, you said already it is nitrogen and hydrogen. Yeah, again, another example.
sulfuric acid,
Yeah, which all things are there in sulfuric acid?
sulfur,
Yeah,
hydrogen and oxygen.
yeah, all the three. All this, I just want to know. That is why when something reacts with sulfuric acid, sulfate is formed. So that is why it will be having oxygen also within this. And any other example of sulfur? Example of compound? Yeah. Any other example of compound?
Carbon monoxide,
Yeah. So how many oxides will be there in carbon monoxide?
1.
Yeah. So that is very important. See the name. See, very often when you name something, you can find out. See, for example, earlier he said carbon dioxide. Di means two. So that means carbon dioxide will contain two oxygen atoms and one carbon atom. Carbon mono means single. So carbon monoxide means it will be having only one atom of oxygen. So that is the difference. Whenever you talk of any sodium, whenever you talk of something, hydrogen disulfide, that means two sulfur atoms will be there. It is not there, but hydrogen like that. So whenever you say di, that means two atoms of that will be there. Dioxide means two oxygen. So whenever you say monoxide, mono means single. So that is how you can find out from the names. You can find out how many atoms are there and things like that. Trioxide means
3.
yeah, three oxygen atoms will be there. So like that, it can go tetra, penta, etc. So from that one can know how many atoms are there in that compound. So these are some of the examples of compound. Now, when you mix two elements, you can get one more thing. See, one thing you have seen is compounds. Any other thing you can get by mixing elements?
Mixtures.
mixture,
Yeah, that is simply mixture. So what now we have to understand what is the difference between a mixture and a compound. That is also very important. What is the difference?
mixture is defined as when we combine two or more compounds.
No, that means you cannot combine two elements to form a mixture.
Yes, we can.
Yeah. So what is the definition of a compound then?
Definition of compound.
What is the definition of no, I'm asking what is the definition of a mixture? Because we have seen when you combine two elements, you get a compound. But we get the mixture also by combining two elements. So what is the difference between a compound and a mixture?
In compound, we mix the elements in fixed proportions.
In compounds.
Compounds.
Yeah, in a mixture.
In a mixture, we don't.
Yeah, simply we mix. See, there is one basic difference because there is no fixed way. For example, we have seen water. Water has two hydrogen atoms and one oxygen atom. Similarly, like the example he took, ammonia. Ammonia, you know how many nitrogen atoms are there? How many hydrogen atoms are there?
Nitrogen 1.
Yeah. Hydrogen?
3.
Yeah. So there is 1:3. One nitrogen atom and 3 hydrogen atoms. So that is so there is a ratio. So that is one. They whenever a compound is formed, there is a fixed ratio. Wherever it is formed, whether it is formed here or whether it is in formed in because I am sitting in Kerala. So if it is formed in Kochi or whether it is in US, wherever this ammonia is formed, it will be 1:3, one nitrogen and 3 hydrogen atoms or elements combined will form the ammonia molecule. Again, one thing I forgot to mention is a molecule. What do you understand by a molecule? What is the difference between an atom and a molecule? Have you heard of the word molecule? Have you heard the word molecule?
Yes, sir.
Yeah. Yeah. What is a molecule? Can you give me an example of a molecule? Yeah. What do you understand by a molecule? Yes. Tell me. You are familiar with the word molecule, no?
Yes, sir.
Yes, sir.
Yeah. Yeah. Tell me. What do you understand by a molecule? Give me an example. No? See, actually, again, as we have seen, atom is the smallest particle available with the all showing all the properties. But very often in nature, see, for example, hydrogen. Hydrogen atom as such is not found. It is formed as a molecule, that is hydrogen molecule. So you know how many molecules in a hydrogen molecule, how many atoms of hydrogen are there? In a hydrogen molecule, how many atoms of hydrogen?
1.
No, that is
Two.
so in a,
Two.
two. Actually, that is why you always write hydrogen as H2. So that is not an atom of hydrogen. We talk of a molecule of hydrogen. So that means in nature, how they are available. That is, as a molecule, it is available. Similarly, oxygen. Oxygen, whenever we write oxygen, which is available in nature, it is as O2. That means that is the molecule of oxygen will be having 2 atoms of oxygen. Similarly, nitrogen, it will be having N2. And the exception is, can you give me some exception of some gases which has only single monoatomic molecules? See, hydrogen, oxygen, etc. are they are
Helium.
diatomic. Now, tell me an example of a gas whose molecule contains one atom only. Yeah,
Helium.
yeah, all those which we talked about earlier, because they are inert, they don't even interact with their own atoms also. See, actually, a molecule is formed by joining 2 atoms together. So only chemically active elements can do that. Hydrogen atom is highly hyperactive, so it will join with another hydrogen at least and form a hydrogen molecule. Similarly for oxygen, nitrogen, etc. Whereas inert gases are inert, as the name says. Inert means dull; they are not involved in, they are not at all active. So they have they are monoatomic molecules. That means their molecule will contain only one atom. So molecules are something which is most of the matter is present in the molecular form. If that is true for element, and then of course water is is a combination of like two different elements. So that is a molecule. When we talk of water, carbon dioxide, carbon monoxide, all the compounds are basically molecules because the combination of elements or the atoms. When the atoms combine together, they form the molecule. Okay.
Yes, sir.
Now, yeah.
Yes, sir.
Now coming back to the mixture. What is the difference between a mixture and a compound?
In mixtures, the elements are not mixed in fixed proportions.
Yeah, that is true. That you said already. So any other difference? See, suppose you mix two things. For example, I take a example of a solution, water and salt. So if you mix them together, is there any chemical change taking place? The properties. See, what do you mean by a chemical change? Actually, there are two type of things. One is a physical change, and other is the chemical change. What is a chemical change from your observation?
The chemical composition, is there some change in it?
No, actually, one can easily see their properties are changed. For example, when you combine hydrogen and oxygen, it forms water. Does it show any properties of hydrogen? Water, does it show any properties of hydrogen?
No, sir.
And does it show any properties of oxygen?
No.
So you are getting a new substance or a new material or a new matter. When new, I should not say the word matter, you are getting a new material. So that is what happens when a compound is formed. It is not showing the original properties. For example, hydrogen is. Do you know some of the properties of hydrogen? Have you studied some properties of hydrogen? Yeah. Then
No.
no idea.
No, sir.
And Karan,
No, sir.
hydrogen is highly combustible. Do you understand the meaning of the word combustible?
Yes, sir.
What is the meaning of the word combustible?
Flammable.
Yeah, it's highly like it catches fire. So that is why we don't use hydrogen balloons, we use helium balloons because it can cause explosion. So hydrogen has that property, but water doesn't show that. And what is the other? What is the property of oxygen?
Does not support combustion.
It is like for all burning, oxygen is a must. It won't burn by itself, but it helps burning, isn't it? In the absence of oxygen, no burning will take place. So you see, one is something which burns, and the other one is which helps in burning. They join together and form water, which is used to stop fire, isn't it? Water is used to stop fire. So
Yes,
you
sir.
see, a totally different material is formed. Whereas if you mix two elements, they will show their original properties. Then we say it is a mixture. It's simply a mixing. So, and of course, a compound is formed when two elements are joined in a fixed ratio. That is how a compound is formed. And there are reasons for that we will be studying later. Like, have you got any idea why when a compound is formed, there is a fixed ratio? What is the reason for that fixed ratio? Any answer to that? You might have studied about it. Yeah. Why a fixed ratio? Yeah, tell me. Yeah. Are you there?
Yes, sir.
Hello. Yeah.
Yes, sir.
Tell me why a compound is formed when two elements combined in a fixed ratio.
Sir, no idea.
Karan, any idea?
No.
Yeah. See, actually, whenever a chemical change takes, so whenever a compound is formed, a chemical change is taking place. Now, so there is the beauty of this is the basic fundamental principle of a chemical reaction. We have to understand what happens in a chemical reaction. Do you know what happens in a chemical reaction? Actually, what happens is, for example, hydrogen and oxygen. You talked of eight earlier, like neon, all those, except helium, everybody has eight electrons. So when you have eight electrons in the outermost shell, there is chemically inactive. They become chemically inactive. So, and you know how many electrons are there in oxygen outermost shell? How many electrons are there? Yeah,
6.
yeah.
6.
So suppose I give two electrons. What happens to oxygen?
Comes O2 plus.
It will, no, it will become no. I mean, I'm talking about outermost shell from that point of view. I'm not talking about two plus. When two more electrons are given to oxygen, not give, like it is temporarily given on a say, I mean, say shared. That means it will become eight, isn't it?
Yes, sir.
Yes, sir.
So it will become chemically inactive. So now the question is how to get that. When hydrogen has one electron, two hydrogen atoms can give two electrons. So that is why whenever a water is formed, it is known as sharing. It is not actually, it is not shifting from hydrogen to oxygen. It will be shared. The oxygen will say, okay, I am sharing these two electrons with you. So and the hydrogen is partially losing that electron. So it becomes H2O. That means, and oxygen will become inert by that. In water, oxygen will become chemically inert actually, because it is getting two electrons. It is sharing two electrons with hydrogen. So that is what happens when a water molecule is formed. That is why a fixed ratio of 2:1 is necessary for the oxygen to become inactive. So, but then if in the absence of hydrogen, it doesn't take place. So it has to be combined with the hydrogen. Two atoms of hydrogen and one atom of oxygen forms. So with the whole chemical reaction, what happens is, now let us try to understand what is a chemical reaction. In all chemical reaction, this exchange of electrons takes place. See, that is very important. When we have seen atoms have a nucleus, and then you have the shells. I mean, you have these KLMN shells are there, and you know the 2n square rule. Each that 2 into that n is the shell number. So you can say that first shell will have 2, then like the 2, the next will be having n 2n square, 2 into 2 square. Uh, that is the maximum capacity. So like that it goes. So very often outermost shell are known as the valence shell. You know understand the meaning of the valence shell? Have you heard of the term valency? Are you familiar with the term valency? Hello?
No, sir.
Valency of an element.
No, sir.
See, actually, Karan, any idea about valency?
No, sir.
No, never. I don't know whether you have heard or studied about it. Anyway, don't worry about that. See, actually, uh, in the case of oxygen, we will say oxygen, the valency is 2 because it needs 2 electrons to become chemically inert or chemically stable, because it is having only 6. So 8 minus 6, that is its valency. So similarly for hydrogen, how many electrons should be there in the hydrogen shell, it is 2 actually, because first shell is the maximum capacity is 2. So hydrogen needs one more. Already one is there, so it needs to get 2. Oh, so one more. That makes it 2. So valency of hydrogen is 1. Similarly, chlorine. Do you know how many electrons are there in the outermost shell of chlorine? Any idea?
7.
7.
7. So the valency of chlorine will be
1.
Yeah, it will be 1. So because how many more electrons are required to make it 8? That is the general criteria used for in a chemical reaction. But again, there are two types of valencies. One is positive, electropositive valency, and there are negative. See, for example, if it needs one more electron, if it is added, then it becomes negative, of course, because one more electron added means atom will become electrically negative. So this oxygen, chlorine, etc., electronegative. Whereas sodium, how many electrons are there in the outermost shell?
1.
1. So it has to lose, because either one thing is it can take 7 or it can lose 1. So it easy is to lose 1. So its valency is 1, because if you lose 1, it will be again you will see that it will be having 8 in the outermost shell. So sodium. Potassium, how many electrons are there in the outermost shell? Potassium, how many electrons? Yeah.
9.
No, outermost again. See, actually, you will see that lithium, sodium, potassium, all this will have 1 electrons in the outermost shell. So it is easy to lose. So either its valency, they have positive valency, so they are electropositive. That means it has to lose 1 electron and become outermost shell will have 8. So you can do it as a homework. You can go back and check whether what I said is true, because in the case of sodium, potassium, lithium, etc., you will be seeing that if you lose 1 electron, the outermost shell will be having 8 electrons. Whereas in the case of fluorine, chlorine, bromine, iodine, they will be having 7 electrons in the outermost shell. So if they get 1 electrons, it becomes 8. So they have negative valencies. And similarly, oxygen needs 2. So, but it is easy to get 2. And what about carbon? How many electrons are there in the outermost shell? Any idea?
4.
Yeah. So that is why the whole organic chemistry. Earlier we said that organic chemistry, one branch of chemistry, because we have seen almost 100 elements are there, but one branch of chemistry is devoted to its actually carbon and its compounds, whereas other elements, they don't have that kind of uh, uh, status. So all others are combined in inorganic chemistry. Inorganic chemistry than carbon, whereas organic chemistry is solely dealing with carbon and its compounds. So that is how carbon got this superior, because it has outermost shell has 4. So it can take 4 or it can give 4, and all it's so highly flexible. So again, more details are there, but in simple terms, we can say that that is how the this carbon chemistry comes into play. So, so this is the valency. Yeah. So the chemical reaction is about this exchange of electrons. So all this, and that too, only the exchange of outermost shell electrons. So it will be exchange of those electrons take. So only the outermost shell electrons takes part in chemical reaction. So that is Whereas when you are forming a mixture, that exchange will not take place. So they are existing as independent elements. So there is no uh, electron exchange. So then we say it is a mixture. Okay. And then, of course, they are not in a fixed ratio also. Okay.
Yes, sir.
Yes, sir.
Now, before we close this basic discussion, I would like to ask you what is a solution? What do you understand by a solution? If we have, yeah, give me some examples of solutions. Yeah.
Solution is the combination of solute and solvent.
Yeah. Say, for example, okay, give me an example.
Water.
Yeah. No, water is not a. See, what is the see? What is the meaning of a solvent and a solute? First, let us discuss that.
Sol-
Yeah.
Solvent is something that dissolves
Yeah.
the solute
And
in it.
yeah, what is the solute?
Solute is the part is the thing that gets dissolved
Salt.
in
Yeah. So now give me an example for a solvent. Give me an example of a solvent.
solvent, water,
Yeah. Solute.
solute, sugar.
Sugar. It can be sugar. It can be salt. Like various examples we can take. So now let me ask you this thing. When you are forming a solution is a mixture or a compound?
Compound,
How do you say that? See,
because
because
we can add sugar till a point
yeah,
till
but
the
then
saturation point.
there is not a fix, and it's will the properties of water and the sugar changes when they mix together, when they are dissolved, suppose sugar is getting dissolved into water, will the properties of the sugar changes?
No.
So there is no chemical change taking place.
Yes.
So solution is a mixture, basically. It's a mixture of two, solute and solvent, actually. Okay.
Yes, sir.
So there is no chemical change. So we talk of physical change and chemical change. Can you tell me some examples of a physical change? Have you heard of this physical change and chemical change? Yeah. Yeah.
Can it be water?
No, change, physical change. Example of a physical change. See, for example, physical change means the physical nature of its changes. For example, solid. Ice is a solid. If you heat it, it becomes water. If it's further heated, it becomes vapor. But it is still water, isn't it?
Yes, sir.
So
Yes.
that is a physical change. Any solid, when you heat it, it becomes liquid, or it can be heated further and it can become vapor also. So that is a physical change. Whereas in a chemical change, the chemical composition, for example, if water is electricity is passed through water, it becomes hydrogen and oxygen can come out of it. If you give sufficient energy, hydrogen and oxygen can come out of it. Or if you combine hydrogen and oxygen, you get water. So that is a chemical change because the properties of the original material has changed. Whereas in a solution, that is not happening. So it is a mixture actually. There is no change in the properties. But now let me ask you one thing. This is the last thing I am going to ask you today. When you are adding sugar or salt to water, you know that salt is there, but it is not seen. Can you see the salt?
No, sir.
You cannot see the salt molecule. What happens to salt molecules? Where they are going?
It gets completely dissolved.
What is the meaning of? it is getting completely dissolved. When you use the word, you have to understand what do you mean by getting completely dissolved. What happens to it?
Gets completely mixed.
How? Well, like using the different words will not help you. See, actually, when a solution is formed, there is how it is formed. You have to understand. There are a lot of empty space in between the oxygen molecule. Sorry, water molecules. Actually, the salt molecules or the sugar molecules are going there in between, and then they are getting sitting there. Okay, empty space is there between water molecules, so it will go there. So that is why you said earlier, if you go on adding after certain amount, it will not get dissolved. It will get deposited at the it will get deposited at the surface or at the down bottom of it will get deposited at the bottom, isn't it? If you go on adding sugar, you will see that the sugar will get deposited at the bottom. That is because the all the empty spaces are filled. So that is known as saturated. So it's a saturated solution. Now, can I increase? Suppose I want to add more sugar, what I will do? Or I want to add more salt. Once it is saturated, can I add more salt?
No.
No.
No, you can do that. Tell me how can you do that? Suppose I heat it. Suppose I heat it. It will, you can add more. Why? When you are adding heating, the gap between the oxygen, the water molecules increases. So the more empty spaces are created. But the only problem is when you are cooling, it will come out of it. So a saturated solution will be remain saturated only if your temperature is fixed. If you increase the temperature, it will it can occupy it can have more spaces will be there, so more solute can go. But if you cool it, opposite thing will happen. Okay.
Yes, sir.
So these are some of the and are you familiar with the periodic table? Periodic table of elements.
Yes, sir.
Yes, sir.
So we'll have some discussion on that. Probably in the next, I think I'll have to stop it here today. So as a homework, you have to do that. You have to revise the all the elements and the name of the elements, their electronic configurations, and what I said. You have to find out without looking into the other thing with by just by seeing the electronic configuration. That means outermost shell, how much electrons are there, and you have to find out what is their valence, positive and negative valence. Okay, you have to find, and then you have to check with your text whether it is matching. For example, you are finding that valency of oxygen is 2, and you have to check whether the valency of oxygen is 2 or not. So you cross check. Okay, at least 10 elements you have to find the 10 to 15 elements you have to find its valence. Okay, that is one thing. And the periodic table, of course, you revise it. We'll have some discussion on that. But see, actually, Faber has given you some homework. Have you done that?
Yes, sir.
So why can't you submit it online? Like you can scan it and send it to me and her. That you can do that, no? You have wrote it down, or you have not noted it down?
We have
Question.
written it in the book itself.
No, you send it across through WhatsApp. Okay, can be done.
Yes, sir.
Yes, sir.
And after that, if you have any doubt about that, we'll discuss it. Otherwise, you send it across, huh? To me as well as to Feba, because probably I might be taking some of the chemistry classes, so I may have to see that also. Yeah. So I now time for you to just 5 more minutes. So it's time for you asking questions which we have discussed today. Yeah. Yeah. So you don't have the habit of asking questions?
Sir, can you one more time explain the differentiate between compound and mixture?
Yeah. See, in simple terms, we can say that when a compound is formed, uh, a chemical change takes place. That means the two elements or two molecules join together and form a new material. So that is what happens when a compound is formed. So you have a fixed. So whenever a compound is formed, there is a fixed ratio of the molecules. Say, for example, I have said one is water, two hydrogen atoms and one oxygen atom, carbon dioxide, one carbon atom, two oxygen atoms. So like that. Whereas when a mixture is formed, there is nothing like that. There is no ratio. You are simply mixing them together. That is why the name mixing. They are simply mixed together. There is no chemical change take place. Their properties will remain the same. The example I talked about, a solution is an example of a mixture actually. Or if you mix two, like iron and copper powder, so they will remain as iron and copper powder with that. So if you show a magnet, the iron will come out in the magnet. So that is the difference between a mixture and a compound. Because in a compound, the original material is changed in its property. So you talk of a chemical change. Whereas in a mixture, there is no chemical change take place. Yeah. Yeah.
Thank you, sir.
Is it okay? The
Yes.
explanation? Yeah. Yeah. Any other question?
No, sir.
Yeah. Karan, any other question?
No.
Yeah. Anyway, can you switch on the video? I can just see you, and if you don't mind, I can also switch on my video. Is it possible? This is me. Then we will say good night. Yeah. Yeah. So I was calling you Karan again. So let me try to understand your name. So you are
Karen.
spelling
K
K-A?
R-E-N.
Karin. So I don't know. I may not be able to pronounce it properly. And you?
Abia.
Abhya. So that is easy. But so, sorry for calling you Karan, but I will be calling you Karan only. So don't mind that. Abhya. Okay. Yeah. Okay then. You can send your question. Any further questions, you can send it through your WhatsApp group. Like I think you have the either you can send it to Feba, she will forward it to me, or you can send it to me also directly. You have my number. You have my number, no? Today, you have my number.
Yes.
So you can send it to me also. Yeah. Okay then. Good night. Huh?